Okay, we'll go and get started. It's my understanding that from yesterday we did not finish something, and that would be what? Okay, so I heard copper 2 sulfate. Okay.
But it was like written out.
Okay, well, we'll take a shortcut through the woods. Okay? So what I want to ask you is, why is this going to react?
Because zinc is higher than copper.
Okay? So to answer that question, okay, when you're looking at this, we've got this arrow, here. Okay? Where is copper in the activity series?
It is lower than zinc.
It's lower than zinc. So what that is telling you, that this is more active, so this will replace the copper. Okay? And with that, we know we're going to form some zinc sulfate and some copper metal. And what part? The reactions? Correct. Okay. So who wants to balance this?
It already is.
See, I didn't know if anybody would come up with that or not. Okay. Because what we maybe should have done is say that this is copper 1, okay, which really wouldn't change this a whole lot. If it's copper 1, okay, negative 2, okay, charges will not change, and then this would be 0 over here, okay?
Wouldn't the sulfate be +2?
I'm sorry. Oh, yeah, okay, yep. I knew that it canceled each other out, except for I just did not write it. We got it right over here, okay? So now, when we look at this, if you had to, and maybe it is a guess.
It's single.
Okay? Whoever said that, single replacement, why is that correct? Yeah, because the best way to look at this is we've got a lone metal right here. Okay? So then this lone metal being higher in the activity series will replace this copper. This will react, and you would get your zinc sulfate and your copper metal. That will happen. And again, that's why you have this. I can't speak for students like, well, Presley comes to mind, Elena comes to mind. Students that are going into the medical field that are probably taking college chemistry right now. I can't speak for them. I would be led to believe that they would probably be given a chart like this. Maybe, maybe not. I can't tell you for sure. I don't think you would have to memorize this. I don't even know if that's even possible. Well, it is, but I just don't think that would happen. Okay. Now, was there any other reactions from yesterday besides this one that we did not discuss?
Wait, what's that one called?
Single replacement. Okay? And then what I want you to think about, and this is going into tomorrow, okay, what we call oxidations and reductions. And what that means is, what do you suppose it means if you are decreasing in charge? Is that
The charges are getting smaller.
if the charges are getting smaller? What do you think that would be, an oxidation or a reduction? That would probably be a reduction. So therefore, what element do we see that has actually decreased in charge? No.
Wait, what one are you doing?
Sorry, this one.
Oh, copper.
Okay? Because on this side, okay, and this is leading into what we're talking about tomorrow, this being a +1 charge, okay, what we see happening is if it was +1 to get down to 0, that must have gained something. So what is it that has a negative charge? Okay, what type of particle has a negative charge?
Electron?
Yeah, electron. Sulfate was correct too, with a very vague question. So an electron has a negative charge. So what that must mean then is this gained an electron. So when that happens, and we'll continue to go over this and over this, okay? Okay, these are your two reactions right here. Oxidation and reduction. Okay, so then this, in an oxidation reduction, we're talking about electrons. Would you guess this is gained or lost? The L. Yeah, it must mean that it was lost. So in a reduction then, we're talking about electrons. They must have been what? They must have been gained, okay? So you could look at that as far as a reducing in charge, where this went from +1 to 0, okay? And then, and this is a very difficult concept to wrap your head around. That's why we're not going to wait till December and go over this and say, by surprise, guess what? This is on your final, okay? We want you to be prepared for that. So then, what do we see is happening with our sulfate ion? What does it do? Yeah, it doesn't. Or it doesn't. It doesn't do anything. So it's what we call a spectator ion. Okay, so anytime you're participating in a sport, okay, football, volleyball, basketball, anything of those natures, people who are sitting in the stands, we call them spectators because they are not doing anything in reference to the game. Okay, so they just sit there, I suppose you could say, cheering on your copper, or which is really dumb to say, I guess. But now, when we look at our zinc, this has a neutral charge. So now, if this went from 0 to +2, okay, and then this is a good way you could look at it as well. Should be 30, right? 2, 4, 6, 8, and 10 is 18 plus 12 gives you 30. And these are very special electrons. What are they called? Valence electrons. So now, these are probably going to get donated, so that is not there anymore. So we have 30 positive charges. And how many negative charges do we have?
28.
So what is our net difference there?
2.
That's why this goes from 0, when it's neutral, over here to +2. So what happened to these electrons? Were they gained or lost? They were lost. So if they're lost, that's telling us that is oxidation then. Okay. Oh shoot, I didn't mean to erase that. Darn it. Okay. We had this up here. First of all, what would that be called? This acts as one ion right here. It's the now I can't say it. It's the permanganate ion. Okay? This is an important aspect of organic chemistry because some substances get oxidized all the time, and what's happening then is that's an example of what this does is it probably goes through oxidation, which whatever it's reacting with. So if we want to do a single replacement reaction, do we have a whole bunch of metals we could put in here? Because if not, we're going to end up with that. So is there something that we could pick to avoid this? And there's only one answer. Not hydrogen. It is a metal. Not silver. You went to the wrong side when you said silver. No. No. Nope. 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 And then when I tell you, you're going to say, I guess I knew that. Nope. Why is lithium the correct answer? Seriously, did he say lithium?
You didn't hear me say lithium.
Anya said lithium.
He did say lithium?
No, Anya.
I know back there. I'm talking about up here.
I guess I didn't say lithium.
No, your lab partner.
Yeah.
Your lab
He
partner.
wasn't listening. He wasn't paying attention.
Okay.
He's a very bad.
So now,
On this side.
so if we were to do this, now we've got this written correctly. Now this would be correct. Now because we're saying no reaction. But if we wanted to change this to where we do want this to react, there's only one correct answer, and it is this one. Now, I want you to think about this. Okay? You might have thought that, well, maybe it's this, which I would say is probably a pretty good presumption. But what type of state of matter are we talking about here? Hydrogen's a gas, okay? So that's probably going to make a difference on why we would not want to use that. There's probably something more specific, but that will be at a later time. But what does lithium have in common with hydrogen? If they're in the same column, why is that so important? So now we see that similarity. There's just one electron in, and that gets stripped out of there very, very easily. Okay? So what I want you to think about is if you're talking about decreasing activity, what do you notice about the mass of these elements? And maybe not even the mass. What subatomic particle is way bigger down here than it is up on top? Well, it's really heavy, but look and see what we have inside the nucleus here. How many protons? We've got 3. So by the time you get all the way down to gold, okay, you're looking at 79. That is a lot of positive charge holding on to those electrons. Okay? Now, that might not be the case for all of them, but let's look at atomic numbers. Okay? Gold, like you said, 79. So we're all the way down here. Like I said, it's not 100% accurate because we see that lead and mercury have more protons, but yet they are higher in the activity series. So again, there's probably different reasons for that just because of where the electrons are placed in the electron cloud. But it could be because they're in the P block. That probably have a lot to do with it too. That's correct. Which I didn't think of, but that is a very good answer to give. That would make sense. Okay. So now we got this to react. What are we going to form in this single replacement reaction now? So lithium with a what charge? Permanganate with what charge? Okay, and then what's left over? Okay. Banana. Yeah. Yeah. You're just thinking this for a million reasons. That's a lot. That's a lot of reasons. Seriously. Yeah. Yes, this is a single replacement. How do we know that this is a single replacement reaction? Well, yeah, but that's not a very good reason, though.
Swap the two elements that weren't polyatomic.
Yes, that happens in double replacement reactions, too. That, okay, you're getting closer. That is a very good clue. You're only doing one switch. That's correct. So what I want you to think of, these are all the same types of reactions. So how could we change this if we did this now? What would your guess be if that was the reaction? Yeah, so this is no longer it'd be a double replacement. So going back to what we had, how do we know that this is a single replacement reaction? What do we see something all by itself? Right, you see a metal all by itself. When you see a lone metal, okay, and it doesn't always have to be this lone metal. It could be hydrogen too if it's by itself. Okay? Sorry? So it's alone, yes. It's probably going to be a single replacement reaction. That's probably, for our purposes, a good way of looking at that. Okay. What about having to balance this? We're not quite done yet. Something is wrong on that side. No. Well, but that's already written that way. You're not wrong, but we're not right either. There's something wrong on that side.
Which one are we on? The second one down?
And where are those charges not right? You are correct.
That is not a question for me.
Oh.
It is right. Are you saying potassium?
What does the permanganate have for a charge?
-1.
Okay. Then I had it, yes, it is balanced. For some reason, I had it in my mind that this was -2. So yes, that is written correctly. So my mistake, your fault, but yeah. Yeah. See? Isn't that how it works? Doing what?
We stepped off the bus there.
Okay, yeah. So I'm honking my horn saying get back on the bus here. Okay. All right. And I think it's because this, okay, what does that have for a charge? That has a negative. I had that in my mind for some reason. Okay. I had the dichromate in my mind that was because that's a powerful oxidizing agent too. So is there any questions over this before I erase it? No? Okay. Now, with the bottom one is a separate type of reaction, but what I want you to do is look at these two that we have remaining. One of them is correct, one of them is incorrect.
I see 3 remaining.
I said other than the bottom one. Yeah. Of the other two then, one of those is correct, the other one is incorrect. We're saying the bottom one is incorrect. If you said that, you are correct, but it's more important to know why you are correct.
It's not balanced, right?
Well, disregard the balancing.
Well, you took apart the permanganate, didn't you?
No, we're talking about the two reactions that are up here on the board now. Someone who said something about the bottom reaction, not the aluminum and oxygen, but I'm perceiving they're talking about this.
Yeah, that one.
Why is this one not correct?
On the CrOH3, there's 3 OHs, but there's charge of CR2, and the OH is 1.
You would think so, but no. Okay, so let's look at this. -1 plus 2. So this, if this is -1, this has to be +3. And then we would say this is +3, but really it's 0. But so going back to who said this, someone said that this is written incorrectly. That's why we said this is correct, that it's not, but it's more important to know why that's incorrect. Okay, where is this in your activity series? Okay, well, look at what we see here. When we see magnesium, that is 1, 2, 3, 4, 5. It's 6 from the top. Where is chromium from the top? About what, 9 or 10?
Yeah, it's lower.
So this is lower in the activity series. This, being less active, cannot replace that magnesium, no matter what you do. So that would result in a no reaction. And that's why we wrote it this way, because otherwise we're just guessing. Because now when you say that this is correct because there's no reaction, we say, well, so why is that right? Well, it's because the activity series would tell you that that's right.
So can we write it where it is correct, like where you flip them around?
If you did flip them around, it would be correct. Okay? So we would have to change that just a little bit, which I never really thought of doing, but is actually a good idea. Okay? So we are going to flip these around because we don't know if that charge is correct. Okay? So then you'd see, if we flip these around, here's our magnesium, and then here is your chromium. Okay? So the last thing you have to do then, okay, what do you want, 2 or 3? Because it does make a difference. Okay? So if you're saying chromium 3, then that means this is +3. This is still -1. So is that correct? No. It is not. We need to have what there instead? 3. Need to have a 3 there. Okay? Do we do anything with this magnesium? No, we do not. It's got a charge of 0 because it's stable right now. Magnesium has a +2 charge. So what does hydroxide have? So that doesn't add up to 0. You need 2 hydroxides then. Okay? And then of course that charge would be 0. Okay? Do we have an element or an ion that has no bearing on this equation? We call them spectator ions. What might that be? Yeah, this is -1 on this side. It's -1 over here. So really, there's a different way that you can write this, and that's a little more for advanced students. Okay? So now, how would we go about balancing this? Okay, so 2 here would be right. Okay. Then what? You need a what? A 2? Oh, Gesundheit. Okay. All right.
Was that a French?
I don't know.
You were just throwing them out there.
I don't know. I'm just throwing it against the wall and see if it sticks.
They've been sticking, don't worry.
Okay. All right. Okay, front row, are we on the bus here? Back row, are we on the bus? Okay, now, let's not relive our freshman year, and go in with the idea, I'm just going to nod my head yes, just so we don't cover this anymore. If you do that, I highly, highly recommend that you talk to someone who has a good understanding of this, because otherwise, the example that we gave, if you're on the football field, okay, and here's the runner, here's the defense right here. I got this backwards, don't I? Well, he's got the ball, okay? So here's the running back, gets to the sideline and then goes like this. What should this guy, should he go like this and then try to catch him from behind? No. You need to take an angle on that. So my point is, if we don't understand this, this is what you're doing. You're already behind and you may not get caught up. Okay? All right. Have we had enough? We'll do the last one. I think that's important. Okay, so if you had to guess, and maybe that's what we could say at this time, what type of reaction would you guess that this last one is? Why are you right? Because you are putting these two together. So what's the symbol for aluminum? Okay, what is oxygen? O2. Okay, and then what do we have over here? Okay, now, oops, you did not see that. That was not there. Okay? But that's not there. See, it's not there anymore. Okay? Because what we want you to do is always start with your negative charges. What does oxide have for a charge? -2. What does aluminum have for a charge? That does not add up to 0. Because what's your least common multiple? So again, and there's nothing wrong with this, 6 divided by 3 and 6 divided by 2. That's what I said. You did not see that. Okay? Now, don't get hung up with this. This is not a value. Okay? Because it's a charge. We got +3 in protons, -2 in that of extra electrons. So that's why it's just showing you the charge, not the value. Okay. So then I think the last thing that we want to do is, what type of charge does aluminum have?
+3.
Well, over there, but over here though.
0.
What does oxygen have for a charge over here?
4. -0. -6.
Okay? We're going to start with this tomorrow. But I want you to think about, okay, what has happened here and what has happened here. Okay? That's where we'll start tomorrow.
What is the oxygen called? What is it called?
Oxide. Now,
Yeah, no,
Diatomic.
oh, yes, it's diatomic. Okay?
so what's that thing? What is that called? Like, what and
This one? Synthesis.
That's what I remember.
Well, don't let the cat out of the bag yet.
Isn't that right?
Well, maybe, but we said we're starting with that tomorrow. I don't know. Today's the 18th. I don't think it's the 19th yet. Are you over in Korea or what? Because it's already tomorrow in Korea. Okay? So We'll start with what's happening here tomorrow. We'll catch up to you next time.